the lesson. Last time we talked about some things like elements. I hope we have the idea of an element now. Yes? Elements. Sean? Sean?
Yes. Yes, teacher.
We talked about elements, didn't we?
We did.
Good. Then we saw how elements help us form what we call a compound. Inside an element, we have the main basic important thing in an element is called what they are? Atom. Isn't it?
Yeah.
Okay. So since we have those, let's look at this. How do you know the boiling point of something? Boiling point of any given substance. How do you know that that thing has reached its boiling point? I want ideas. Mm. Mm-hmm. Do you know the boiling point? Hmm? What is boiling?
Something heating.
Something heating. Very good. So what do we call the boiling point? According to you, what is the boiling point?
According to me, I think the boiling point is where the temperature rises of an element.
Temperature rises of an element. Yes, that's a good trial. Someone can put it better. Gift. Gift. Gift.
Yes, teacher.
Very good. What is boiling point according to you?
A boiling point is when an element rises from a low temperature to a higher temperature.
Yes. Okay. Thank you for the trial. Pav.
Yes.
Boiling
yes,
point.
Teacher.
Boiling point.
A point of time when any element is heated and its temperature rises.
It is heated and the temperature rises. Now, okay, I've got people's ideas. Shelly. Somebody using Shelly's name here. Yes? Shelly. Shelly? Shelly is quiet. Then somebody called Rebecca. Let me hope this is not Madam Rebecca. Am I talking to Rebecca? Tracy? Tracy? Okay. So the boiling point of something is, you know, when water is boiling, it starts from, let's take an example. It is in the ice state. When it changes a state from ice to a liquid, it is called freezing. It's called melting. It has just melting. Now, when this changing state from liquid to what we call a gas, there is what is called evaporation. Evaporation. Now, if you heat a liquid, there is a stage it will reach, and this water starts turning to vapor. That point where the liquid turns to gas, to gas or vapor, is what we call the boiling point of something. The boiling point of that metal. At a stage when water just starts turning to vapor, because all the water now has ability of turning to vapor. When it reaches that stage, as long as you reach that stage, it will turn to the vapor stage. So when water is just that energy that is enough to make the liquid or anything that is in liquid state to escape to a gaseous state, you have reached the boiling point of that substance. So even the melting point is that stage when that solid ice you have immediately you reach that solid stage. When that solid is turning to liquid, immediately that solid start turning to liquid. That is called the melting point of that substance. It is that temperature that you reach to, and it allows the substance to turn to another state. Now here, when you go down, we looked at an element being, okay, a pure substance down here. If something is pure, then you must know, if you must know it is a purity. So if you want to determine the purity of a substance, you investigate two things. Number one, the melting point, and the boiling point. Those are two. Melting and the boiling point. So if you want to know that something is pure, know it is melting and the boiling point. That is what you need. So we looked at here. This is an activity that you will do for those who have a fridge at home. We would have done it from here, but now since we don't have, we are not close to each other. If you are near home and you have a fridge, get your ice. And now the thermometer is always going to block us from doing this. Okay, for now, let's just understand what it takes. Then maybe when you get time, you look through it and then you see. So here they are trying to say, put 100 grams of ice made from distilled water into a plastic cup. Insert the thermometer in the ice cup. Immediately start the clock. Watch the ice as it melts while occasionally stirring with the thermometer until the ice completely melts. Stop the clock as soon as the ice completely melts and note the time taken for the ice to melt. Repeat the procedure using ice from tap water. This is ice from any other thing, but now here, repeat the ice made from tap water. Record your findings. Now, by the time you finish discovering the two, you will find that ice from tap water and just ice you made from some other substances differ. They have two different melting points. It indicates that one of them has what we call an impurity in them. So the more impurities you have, the more the purity of that substance deteriorates or disappears. So immediately that one is called the melting point of substance. The more impurities you have, melting point is affected so much by the impurities present in the substance. If you use tap water has many impurities. They use very many things to purify it. So if you test the two with just any other ice you made earlier on, then you will see that distilled water, how to distill water is you allow water to boil and it escapes into the atmosphere. Now that water that is formed due to vaporization or condensation, due to condensation actually, is the one that condenses down and is collected as distilled water. But tap water, you just get from the tap, get ice out of it, and then you test. You'll find out that the two have different melting points because of the difference in the impurities in them. Distilled water is pure This one is impure. You'd have known the pure substance. So here they defined determining pure substance is the one that contains only one type of atom or molecule. But the impure one has many. It has the pure one and then the impure. That's the difference between the two. But a pure one contains only one type of the atom or molecule. So the physical properties of a pure substance include a well-defined melting point and a boiling point. That is when you know that substance is pure. Are we clear with that? Yes? Are we clear?
Yes.
Sean,
Yeah, yes.
how do you know that something is pure?
By knowing the melting point,
And
the melting point
the melting
and
point.
the boiling.
Thank you very much. Now, Pavel,
Yes, teacher.
Yes.
what is a pure substance?
A pure substance is the one which has the same kind of atoms or molecules, same type of atoms or molecules.
Okay, thank you very much. Ruth? Ruth?
Yes.
From that definition Pav has given us, differentiate for us, give for us the impure substance. What is the impure substance? Impure. From your own words, how do you define an impure substance? If the pure one has the same number of atoms, what about the impure one? Hey, someone has gone away. Okay. So the impure one is the one that has two or more different substances combined together in the same element. Is it clear? So if you have 2-3 things combined and you are making one, you are getting impurities in it. An example is tap water. If you make it or you freeze it, it will turn to ice. That ice water will be having very many things fused together. An example of it, it has chlorine. You want to use for purifying it. It has a water molecules. You know, water molecule has hydrogen and oxygen. That one, you are going to look at it in detail. And we shall know what we call an element, compound, and how those elements combine to form compounds, how compounds combine to give us what we call a mixture. So here down, last time we stopped somewhere. We stopped somewhere here on this table. This table is called what? Periodic what?
Table.
Periodic table. This periodic table was discovered by a scientist called Mendeleev. So it's called the Mendeleev's periodic table. So if you looked at the way certain elements react, you see all these elements down here. These elements exist on Earth, the way you look at them. And if you try to count, there are as many as possible. So there are more than this. These are the ones that have been discovered. You can also discover yours if you purify chemistry and you go on with it. You will come to discover more elements. The more you stay in chemistry, the more the head gets it and you discover more. Is it clear? So each element here in this table has a full name and only a letter or two defining them. You see, like this one is hydrogen. The symbol is H. So when you're looking at the element, we look at two things together. We look at the name against the symbol. Now here, you have hydrogen as H. If you had put H as helium, the symbol would look the same. Now, how would you differentiate between the two? That is how they differentiated it, by putting a capital letter at start and then the small letter at the end. Even English tells you like that. When you are starting a sentence, you start with a capital letter, then you follow with the small letters later. So the same applies to names of these substances here. So why we say so is, let me give you a brief definition of what is there, that the symbol of an element is one or two letters only. If you get an element with more than two symbols, or two letters, that symbol is wrong. You find some element will exist like this one, or an example, this one, Cl. It will exist in more than 3 ways. Cl, Cl, Cl. It is only some numbers that change, but they will still remain the same, Cl, Cl. When you reach there, they will give you a definition of that word that is called isotope. Isotope. That is the name given to that substance that has the same element, but different mass number and the same atomic number. I'm going to give you a brief definition of all those terms, but for now, we are after the element and the symbol and the name. So here, when you look at this, all of these are here. CD, when you look at them, they have 2 letters or 1. 2 letters or 1. Which means one of the element, which means only one atom can have that name, not 2 of them. They don't share the same name or the same symbol. Okay? Some of the elements are represented by the first letter of the chemical name. Some of them, if you look at them like hydrogen, is represented by the first letter of the name. Even helium has He, first 2 letters of the name. Lithium, first 2 letters of the name. Beryllium, first 2 letters of the name, Be. When you come to P, is phosphorus. For example, hydrogen and many others. So while others are represented by, now when you come to this, sodium is Na. Here the real name is Sodiume, but the symbol is Na. What causes that difference? The cause of the difference is some of the names were copied from the Latin name. You know the Latin language? Yes? Have you ever heard of Latin?
Yeah.
So that Latin name is the one where they copied the symbol from. An example, sodium is Na. The Latin name is natrium. Natrium, that is sodium. Even most of them here, like iron. Iron is here, it is Fe. The name is iron, but the Latin name is called ferrum. That's how they came up with that name called Fe. The Latin name is the one that gave us the symbol of iron. So if they find you writing iron as I, you are writing something else. I is here, iodine. Okay?
Yes.
Let me hope you are getting me right. If there is any complaint, please complain before we go on. We are discovering why these elements have these funny names and symbols. Like here, boron has B, the first letter of the name. Carbon has C, the first letter of the name. Nitrogen has N as the first letter of the name. Oxygen has O as the first letter of the name. Now, when you come to sodium, instead of S, they put Na. Why? It is derived from the Latin name called natrium. Magnesium is Mg. Aluminium is A. That one is sincere. Phosphorus is okay. Silicon is okay. Which other name? Potassium, instead of P. Potassium, instead of P, they put K. You get it? So there is a Latin name for potassium. So I'm going to give you the first 20 elements that you are going to help you study this. Get somewhere to write.
Okay.
Are we prepared?
Yeah.
Are we there? The
Yes.
first element is hydrogen. The first element is hydrogen. You put the name up and then the symbol. Put the name and the symbol. If it has only one letter, it must be a capital letter. So hydrogen is the first. Hydrogen is the first. Hydrogen is Hydrogen. That's hydrogen.
Yeah.
The symbol is what?
H.
The
Is it small or H, capital?
capital H.
Capital H.
Capital H. Thank you. 2. The second one is helium. Helium is Helium. The symbol is H small e. Capital H small e. Now where you put that cross of the H is where the E should also stop. You have seen where mine is, where the H is. Where that cross of the H stops is where the E should also start from, going downwards. Those are the rules of writing small letters, isn't it?
Yes.
Yeah. So if you put for us a different symbol, we shall cross. The third one is lithium. Lithium is Lithium. 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 And the symbol is L small I. Capital L small I. That is the way you write small I, with a bend. Lithium is like that. If your I does not have a bend, you write like this, Li. We never have I that looks like this. It's not there. So the correct symbol is L small I. Is it understood?
Yes.
Okay. So the fourth one, this is 1, 2, 3. We are going to write 20 of them. 20 elements, the one they teach. Mostly the ones we will find mostly at this level of education. They are mostly 20. And they are called the first 20 elements in the periodic table. The first 20 elements, the periodic table. So when you look at this table of ours here, when you look at this table of ours, you see this first one up. Yes?
Yes.
Where my cursor is here. That is the first one. This is the second one. This is the third, fourth, fifth, sixth, seventh, eighth, ninth, and the 10th. Then this is 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Have you seen where 20 stops? Okay. So the fourth one is beryllium. Beryllium. Berylium. That is beryllium. My camera is disturbing a little, but hope you endure with it. So that is the name, beryllium. The symbol is Be. Be, like that. The fifth one is Someone read for me the fifth one.
Boron.
Boron. B-O-R-O-N. And the symbol is capital B. Now you find that all these elements have their names considering the first letters, first or second letters of the name. That is how you get the symbol. Number 6. Ruth, number 6 is what?
Carbon.
Carbon. Thank you. So C-A-R-B-O-N is carbon. The symbol is C. Now, when you see me writing this C, you know chemistry has started. The 7th one is gift.
Nitrogen.
Nitrogen, okay. Nitrogen. Nitrogen. And the symbol is N. That is the symbol of nitrogen. Gift. The next one.
Gen.
Gift.
Yes, teacher.
The next element, number 8.
Oxygen.
Oxygen. That is oxygen, and the symbol is O. Go to number 9. Who is the next person? Shelly. Shelly. The next one. The next one is what? The next one is fluorine. Fluorine. F-L-O-U-O-R-I-N-E. That's fluorine. And the symbol is F. The next one is neon. Number 10, we have neon. Neon. And the symbol is Ne. Ne. Those are the first 10 elements. First 10. Now we are going to look at the other 10. Number 11, we have sodium.
Sodium.
Sodium. Sodium is Na. The symbol is Na. Never write sodium with S, because it is derived from the which name? The Latin name, isn't it?
Yes.
Yes.
The Latin name is called natrium. The common name is called natrium. N-A-T-R-I-U-M. That's the Latin name. Latin. That's how they derive the name as Na. 12, we have magnesium. Magnesium. The symbol is M small g. M small g. They removed A from this. Instead of writing MA, they wrote for us MG. So when you find MG somewhere, you know that is magnesium.
Magnesium.
Okay. The 13, we have aluminium. Aluminium. Aluminium is A-L-U-M-I-N-I-U-M. That's aluminium. Aluminium is like that. And the symbol is A and then L. That L must have a bend. That is the way you write small L. Not this one of yours, not this. This is not small L. So remove this from your writing. L must have the bend. When you reach senior 3, when you write AL with this type of L, and you find they have crossed it, don't complain. Okay? Someone, if you're in a noisy place, try to reduce on your noise. Unless else mute your microphone.
Mute.
Okay.
Mute.
14. 14 is the
Carbon.
Sulfur.
14. is
Silicon.
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 Silicon. That is the name. And the symbol is SI. SI. Number 15 is
Phosphorus.
Phosphorus.
phosphorus. Phosphorus. That's the way you write phosphorus. Phosphorus. And the symbol is only P.
Capital P.
Capital P.
They pick it from the first letter of the name. 16.
Sulfur.
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 Sulfur. And that's the way you write sulfur. The symbol is capital
S.
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 So you have known the difference between sulfur and silicon. The reason as to why
Yeah.
they did not put silicon sulfur as S is because there's another substance that has Si somewhere. So S is for sulfur, then silicon is Si. 17.
Chlorine.
Chlorine.
Chlorine. Chlorine. When you study chemistry, you will find that this is a substance they pour in water to make our tap water clean and fresh to be used. The symbol is C and small l. That small l must have a bend. Chlorine. Then 18, we have what?
Argon.
Argon. Argon. And the symbol is Ar. That is the way you write argon. Argon is Ar. If you write A alone, it is upon you. That is another symbol in chemistry. So 19, we have what?
Potassium.
Potassium.
Potassium. Potassium has double S. And the symbol is K. It is got from a Latin name called kalium. 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 That's how it has K. Kalium is Ka-Luim. Have you got the difference?
Yes.
20 is
Calcium.
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 Very good. This is the main component in our teeth, by the way, or in a bone, isn't it?
Yes.
Our bones are composed of calcium. So you must know this one, that if it's calcium, the symbol is capital C. Capital C and then small what?
A.
Small a.
A.
Those are the first 20 elements in the periodic table, and you must do them by hand.
Wow.
Someone is saying, wow, now chemistry has started. Huh? Are they hard to get?
No.
No. Yeah, just know that if hydrogen is the first element and the symbol is H, when they ask for helium, you just add the HE. Lithium is Li. Beryllium is Be. Boron has only B. And there are very few elements here that have 2 letters. There are few. Now, as you go on, you are going to find many elements and others, because iron is commonly used. Even in the metals we have, there is iron. In the nails, all those nails are made of iron. Good. Then you find others like copper. Copper is the most expensive metal found on earth, isn't it?
Yeah.
Yes.
Just a tiny piece, you are rich. So you must know the symbol of copper. So that when you see it somewhere, you know this is a copper. Okay?
Yes.
We are going to look at others, but the first 10, 20, we must know them by heart. Okay, we shall join back after this 1 minute here. After 1 minute, we join back. Is it clear?
Yeah.
Okay.
Yeah.
So, is there any question before?
Teacher, the symbol for iron and iodine, are they the same?
They are different. Iron